Hello and welcome to Wave of the Day, the podcast where we unravel the big ideas shaping AI and beyond. This is our 5th episode, and I can't wait to dive into today's topic, auto-encoding variational Bayes. Armin, I hear you've been especially excited about this one.
That's right, Emily. This paper by Kingma and Welling is a game changer. They've introduced a whole new approach to making complex statistical inference much more practical in machine learning.
Okay, before we dive into the technical stuff, can you give our listeners the elevator pitch version? What's the big deal here?
Imagine you're solving a giant puzzle but can only see a few pieces at a time. Traditional methods would take forever, but this approach uses a system that learns patterns and makes smart guesses on how everything fits together.
Oh, that's interesting. So it's like having a really clever assistant help you solve complex problems faster.
Exactly. The key to this is something called the reparameterization trick. It's a clever math hack that makes the process run smoothly. Normally, statistical equations can hit roadblocks, but this trick helps us get past them.
Hold on, reparameterization trick sounds pretty technical. Can you give us a simple real-world example?
Sure, think of cooking a new dish without knowing exactly which ingredients to use. Instead of guessing randomly, you have a taste tester giving you instant feedback, helping you adjust as you go. The trick converts this guessing game into a more guided process.
Ah, that makes a lot more sense. I also saw something in the paper about a variational lower bound. How does that fit into all of this?
It's like having have a guarantee on the quality of your recipe. The variational lower bound sets a baseline for how good the result will be, so you know it won't be worse than that score. This helps us make steady improvements over time.
I love how this connects to real-world applications. What kinds of problems does this method help solve?
The applications are vast. It's used for things like generating realistic images, helping robots understand their surroundings, and more. The paper highlights its use in variational autoencoders, which have been a game changer.
Autoencoders. That's a new term for me. What's special about them?
An autoencoder works like a smart photocopier. It takes an input like an image, compresses it to the essential features, and then reconstructs it. The smart part is that it learns which details are important to keep and which ones to simplify.
That's fascinating. The paper also mentioned recognition models. Is that related to the compression process?
Exactly. The recognition model is like the brain of the system, identifying important features in the data. It's similar to how our brains recognize faces or objects from patterns we've seen before.
This reminds me of how artists capture the essence of a scene. They don't include every single detail, but they highlight what's crucial to make it recognizable.
That analogy is spot on, Emily. Just like how different artists can paint the same scene in unique ways, these models can learn different ways to represent the same data. The magic lies in making it efficient and mathematically sound.
This has been absolutely fascinating. Before we wrap up, what do you think is the biggest impact this research has had on the field?
Its biggest impact is making complex, probabilistic modeling practical for real-world use. It's unlocked new possibilities in AI-driven creativity, scientific research, and so much more. And the most exciting part, we're still just scratching the surface of its potential.
That's all for today's episode, everyone. From clever mathematical tricks to practical AI applications, we've explored some truly groundbreaking ideas. Thanks for joining us on Wave of the Day by Smartest.ai. Be sure to catch us next time for more thought-provoking discussions at the edge of technology.